Space is the most hostile environment humans have ever entered. From mysterious sounds that shouldn't exist, to astronauts drowning in their own helmets, to cosmic events that could erase civilization in minutes, the universe has shown us exactly how fragile we are. Today, I'm counting down the 8 scariest space incidents and phenomena ever documented, ranked from unsettling to absolutely existential. And trust me, the final one will make you question whether reality itself is safe. The knocking. On October 15, 2003, Yang Liwei became China's first astronaut in space aboard Shenzhou 5, 21 hours alone in orbit, more than 300 kilometers above Earth. Then he heard it, a rhythmic knocking sound. Not from outside the spacecraft, not from inside either, just knocking, like someone tapping on metal with a wooden hammer. Here's the thing, sound doesn't travel in space. There's no air, no medium for vibration. Yang pressed his face against the porthole searching for debris, micrometeorites, anything. Nothing was there. The knocking continued throughout the mission, started and stopped without warning. Yang later admitted he felt worried, nervous, and deeply uncomfortable. But here's where it gets weird. The knocking happened again, Shenzhou 6 in 2005. Different spacecraft, different crew, same impossible sound. Then again on Shenzhou 7 in 2008, 3 separate missions over 5 years, all reporting the identical phenomenon. Yang spent months after his return trying to reproduce the sound using various objects and instruments. He failed. Chinese space officials suggested thermal expansion, pressure differentials, structural shifts from decreasing air pressure. Cool. But nobody has definitively explained why the exact same sound manifests across multiple spacecraft with different crews. Yang himself warned future astronauts before launch that the sound is normal and there's no need to worry, which is exactly what you say when something is absolutely not normal and you have zero explanation for it. The knocking still happens. Nobody knows what causes it, and it only occurs in the absolute silence of orbit, hundreds of kilometers from any other human being. But if you think hearing unexplained sounds in space is disturbing, wait until you hear about the astronaut who almost drowned in his own helmet. A drowning in space. July 16, 2013. Italian astronaut Luca Parmitano floated outside the International Space Station during what was supposed to be a routine 6.5-hour spacewalk. He'd already completed his first 2 tasks more than 40 minutes ahead of schedule. Everything was going perfectly. Then he felt something cold and wet on the back of his neck. Water inside his helmet in the vacuum of space. Within minutes, the water pool behind his head crept over his ears, covered his visor, and reached his nose. A clogged filter in his suit's cooling system had failed, dumping approximately 1.5 liters of water directly into his helmet. Then the sun set, total darkness. And here's where it gets absolutely terrifying. Parmitano wrote later in his blog exactly what happened next. The water covered his nose, which he described as a really awful sensation that he made worse by shaking his head while trying to clear it. But shaking your head doesn't work in zero gravity. The water just spreads. His eyes became useless. His communications died. He was now blind, deaf, and unable to breathe properly, alone in the void, fumbling along his safety tether by touch alone. He considered opening his helmet's pressure valve to freeze some of the water through sublimation. The risk was decompression sickness. He also considered cracking his helmet visor during a repressurization, writing that he'd probably lose consciousness, but that would be better than drowning inside the helmet. Let that sink in. An astronaut was preparing to deliberately breach his own spacesuit because drowning seemed like the worst option. It took 24 minutes to get him back to the airlock. Chris Cassidy, his spacewalk partner, reported to Houston that Parmitano's head was saturated with water in his eyes, nose, and mouth. He asked Parmitano to squeeze his hand if he was okay. Then Cassidy added, "I don't think he can." The cause was eventually identified as a clogged filter. The same suit had leaked 1 week earlier but was misdiagnosed as a leaking drink bag. NASA classified this as a high visibility close call and suspended all non-emergency spacewalks. Because you can't wipe your face in a spacesuit. You can't tilt your head to drain water. And Luca Parmitano nearly drowned 400 kilometers above Earth in the one place in the universe where there should be no water at all. But at least Parmitano survived. The crew of Soyuz 11 wasn't so lucky. The only deaths in space. June 30th, 1971. 3 Soviet cosmonauts were about to make history for all the wrong reasons. Commander Georgy Dobrovolsky, flight engineer Vladislav Volkov, and research engineer Viktor Patsayev had just spent 23 triumphant days aboard Salyut 1, the world's first space station. They set endurance records, grew Chinese cabbage, took spectrograms of stars, appeared on Soviet evening television. Patsayev even celebrated his birthday in orbit with veal, cookies, and blackberry juice. The first person to ever do so. It was his last birthday. They undocked from Salyut 1 on June 29th. Volkov joked with ground controllers, asking them to make sure cognac was waiting at the landing site. Everything seemed perfect. Then, at approximately 100 to 60 kilometers altitude, 29 minutes before touchdown, explosive bolts fired to separate the orbital module from the descent capsule. The shock jolted open a breathing ventilation valve. This valve was designed to open only at 4 kilometers altitude to equalize pressure before landing. It opened at 160 kilometers instead. The cabin was instantly exposed to the vacuum of space. Here's the thing, the 3 cosmonauts were not wearing pressure suits. The Soyuz capsule was too small to fit 3 crew members with suits on. They made the decision to fly without them. The medical data is horrifyingly precise. Within 50 seconds, Patsayev's breathing rate hit 42 breaths per minute, a hallmark of acute oxygen starvation. Dobrovolsky's pulse dropped rapidly. By 110 seconds after valve opening, no vital signs were detected in any crew member. Death occurred at approximately 120 seconds. It would have taken 52 seconds to manually close the valve. Far too long. But here's where it gets dark. The automated landing was perfect. Parachutes deployed. Retro rockets fired. The capsule touched down softly in Kazakhstan at exactly 23:16:52 GMT. From the outside, everything looked completely normal. Rescuers knocked on the side of the capsule. No response. They opened the hatch and found all 3 men motionless in their couches, with dark blue patches on their faces and trails of blood from their noses and ears. Dobrovolsky's body was still warm. Volkov and Patsayev were cold. Despite attempts at resuscitation, all 3 had been dead for over 30 minutes. Ground controllers had lost voice contact during descent, but assumed it was routine communications blackout. Nobody knew they had died. The spacecraft landed perfectly. The mission looked like a success. And inside were 3 dead cosmonauts who suffocated in the silence of space while plummeting toward Earth. They were the backup crew. The original crew had been grounded 4 days before launch because one member's chest X-ray suggested tuberculosis. It turned out to be a pollen allergy. After Soyuz 11, all Soviet and Russian cosmonauts wear pressure suits during launch and landing. That policy exists because of what was found inside that capsule, but at least their deaths were quick. The Challenger crew had almost 3 minutes to think about what was happening to them. The Challenger survivors. January 28, 1986, 11:39 a.m. Eastern Time, 73 seconds after launch. Most people believe Space Shuttle Challenger exploded, killing all 7 crew members instantly. That belief is completely wrong. Here's what actually happened. Cold temperatures that morning, 36 degrees Fahrenheit, had stiffened an O-ring seal on the right solid rocket booster. A gap of less than 1 millimeter allowed superheated gas to burn through. At 73 seconds, the external fuel tank ruptured, but Challenger didn't explode. It was ripped apart by aerodynamic forces at Mach 1.92. The crew cabin separated from the orbiter, largely intact. NASA's own Kerwin report confirmed that the forces the crew experienced during orbiter breakup were probably not sufficient to cause death or serious injury. The intact crew cabin continued upward on its own momentum, reaching a peak altitude of 65,000 feet. Then it fell for 2 minutes and 45 seconds toward the Atlantic Ocean. And here's where it gets absolutely horrifying. 3 of the 4 recovered personal egress air packs had been manually activated. Manually, meaning crew members were conscious and taking deliberate survival actions after the breakup. Pilot Mike Smith's air pack was mounted behind his seat and was likely activated by another crew member reaching forward. Evidence suggests Smith attempted to restore electrical power because switches on his panel had been moved from their launch positions. His last recorded word was simply, "uh-oh." The crew module showed no clear evidence of sudden cabin depressurization. The middeck floor hadn't buckled upward as it would from rapid decompression. This means the crew may have remained conscious for much or all of the 2-minute and 45-second fall. There was no parachute, no escape system, no emergency beacon, nothing. The cabin struck the ocean at 207 miles per hour, producing an estimated 200 G deceleration, far beyond any survivability threshold. Author Kevin Cook wrote that the crew were conscious, at least at first, and fully aware that something was wrong. And NASA's Joseph Kerwin estimated they may have had 6 to 15 seconds of useful consciousness after breakup. But if the cabin held pressure, that window could have been far longer. The public narrative was instant death, painless, over in a flash. The reality is that at least some of the 7 crew members, including schoolteacher Krista McAuliffe, watched by millions of students on live television, were alive and aware during a nearly 3-minute free fall into the ocean with absolutely no possible means of survival. They knew. They activated their emergency air. They tried to restore power, and there was nothing they could do except fall. But if you think falling for 3 minutes is terrifying, imagine if a solar storm knocked modern civilization back to the 18th century and we had less than 20 hours of warning. The solar apocalypse. We dodged. July 23, 2012. 2 massive coronal mass ejections erupted from the sun in rapid succession, separated by only 10 to 15 minutes. A prior CME days earlier had swept the interplanetary medium clean, creating what scientists called a clear runway through space. The result was a supercharged solar storm traveling at approximately 3,300 kilometers per second, 4 times the speed of a typical CME, that crossed the 150 million kilometer gap between the Sun and Earth's orbit in just 20.78 hours. It struck NASA's Stereo, a spacecraft, which recorded the full event. Stereo, A survived. Earth did not get hit. The storm missed our planet by approximately 9 days of orbital rotation, 1 week earlier, and it would have been a direct hit. The estimated geomagnetic storm strength was negative 600 to negative 1,150 nanoteslas, comparable to or exceeding the 1859 Carrington event, the most powerful geomagnetic storm in recorded history. During the Carrington event, telegraph systems across Europe and North America failed. Operators received electric shocks, papers caught fire, and auroras were visible as far south as Cuba and Hawaii. Gold miners in the Rockies woke at 1 a.m. to make breakfast, thinking the sun had risen. But here's the thing, that was 1859. We had telegraph lines. Now we have everything running on electricity. Daniel Baker of the University of Colorado stated bluntly that if the 2012 storm had hit, we would still be picking up the pieces. He added that in his view, the July 2012 storm was in all respects at least as strong as the 1859 Carrington event. The only difference is it missed. The National Academy of Sciences estimated $0.6 to $2.6 trillion in damage to the United States alone, with recovery taking 4 to 10 years. High voltage transformers, custom-built multi-ton devices with 12 to 24-month replacement lead times would have overheated and been permanently destroyed across continental power grids. The cascading failures would hit water distribution within hours, food and medications within 12 to 24 hours, followed by loss of sewage, heating, telecommunications, and fuel supply. Supermarkets would empty within 72 hours. GPS, banking systems, and emergency services would collapse. NASA itself said the storm could have knocked modern civilization back to the 18th century. And here's where it gets worse. Physicist Pete Riley estimated a 12% chance of a Carrington-class storm hitting Earth within any given decade. The March 1989 storm, far weaker than the 2012 event, knocked out power across Quebec in 90 seconds, leaving 6 million people without electricity for 9 hours. Tree ring records suggest the sun can produce storms 80 to 160 times more powerful than the Carrington event, occurring roughly every 500 to 2,400 years. We got lucky in 2012 because Earth wasn't in the path. Next time we might not be so fortunate. And when it happens, we'll have about 15 to 18 hours between detection and impact to prepare for the end of modern life as we know it. But at least a solar storm only threatens Earth. The next incident affected our entire planet from 50,000 light years away. The Dead Star, December 27, 2004. SGR 1806-2. O, a magnetar in the constellation Sagittarius, 50,000 light years from Earth. To understand why this is terrifying, you need to understand what a magnetar is. It's a neutron star with the most powerful magnetic field in the known universe, approximately 10 to the 15th power Gauss, or 1 quadrillion times Earth's magnetic field. An MRI machine produces about 30,000 Gauss. A magnetar produces 33 billion times more. These objects are roughly 20 kilometers across, about the size of a small city, yet contain 1 to 2 solar masses. A teaspoon of magnetar material would weigh approximately 1 billion tons. On December 27, 2004, SGR 1806-2 O experienced a starquake, a sudden fracture in its crystalline crust. The resultant giant flare released more energy in 0.2 seconds than the sun emits in 250,000 years. The total energy output was estimated at 2 times 10 to the 46 power ergs, 100 times more powerful than any previously observed giant flare. If this energy release were measured as an earthquake, it would register approximately magnitude 23 on the Richter scale. The largest earthquake ever recorded on Earth was 9.5. And here's where it gets absolutely insane. The gamma ray burst saturated every X-ray and gamma ray detector on every satellite in orbit. It physically ionized Earth's upper atmosphere, briefly shifting the ionosphere from its nighttime state to a daytime configuration. Victoria Caspi of McGill University described it as the flare change in Earth's ionosphere from night to day. Arctic fishermen reported sudden auroral activity at the moment of arrival. The burst was brighter than a full moon in gamma ray wavelengths, from 50,000 light years away. David Palmer of Los Alamos National Laboratory said this might be a once-in-a-lifetime event for astronomers. as well as for the neutron star. We know of only 2 other giant flares in the past 35 years, and this December event was 100 times more powerful. But here's the terrifying part. If SGR 1806-20 had been within 10 light years of Earth instead of 50,000, the flare would have destroyed the ozone layer and triggered a mass extinction, comparable in effect to a 12 kiloton nuclear blast at 7.5 kilometers altitude. At half the Earth-Moon distance, a Magnetor's magnetic field would erase every credit card on the planet. At 3,000 kilometers, it would rearrange the atoms in your body into elongated needle formations. There are an estimated 1 million magnetars lurking unseen in the Milky Way. Only about 23 have been confirmed. As Caspi noted, magnetars are the only deep space objects to directly affect Earth. This one did it from across the galaxy, and we have no way of predicting when the next flare will happen. But at least we can see magnetars coming if we look hard enough. The next incident was completely invisible until it was almost too late. The invisible asteroid. July 25th, 2019, 1:22 UTC. Asteroid 2019 OK passed within approximately 65,000 kilometers of Earth's surface, just 1/5 the distance to the Moon. The asteroid was between 57 and 130 meters in diameter, roughly the size of a football field, traveling at 88,500 kilometers per hour. It was the largest asteroid to pass this close to Earth in over a century. Here's the problem. Amateur astronomers at Brazil's SONIR Observatory spotted it less than 24 hours before closest approach. NASA's Planetary Defense Officer Lindley Johnson sent an internal email stating that because there may be media coverage, he was alerting staff that in about 30 minutes, a 57 to 130 meter sized asteroid would pass Earth at only 0.19 lunar distances. Another NASA official wrote simply that this one did sneak up on us, which is exactly the phrase you want to hear about a city killer asteroid that almost hit the planet. 2019 OK approached from the direction of the Sun, making it nearly invisible to ground telescopes. Its highly elliptical orbit, stretching from within Venus's orbit to beyond Mars, caused it to appear almost stationary against background stars until the final days. A full moon in mid-July had further reduced asteroid discovery rates, all of which means we had almost no warning. Swinburne University astronomer Alan Duffy called it a city killer asteroid and told the Sydney Morning Herald it would have hit with over 30 times the energy of the atomic blast at Hiroshima. An airburst over a populated area could have devastated a region 80 kilometers across. And here's where you need context. On February 15, 2013, the Chelyabinsk meteor, just 18 meters wide, 1/3 to 1/7 the size of 2019 OK, entered Earth's atmosphere and detonated at 23 kilometers altitude with the force of 440 to 500 kilotons of TNT, 26 to 33 times Hiroshima. It injured over 1,600 people, damaged 7,200 buildings, and was completely undetected until it exploded. The flash was briefly brighter than the sun. Over 200 children were among the injured. That was an 18-meter rock. 2019 OK was up to 130 meters, and we spotted it with less than a day to spare. NASA's Paul Chodas estimated such a close approach happens roughly twice per century. ESA noted objects this size strike Earth on average once every 100,000 years. But the disturbing reality is that our detection systems remain incomplete. As Neil deGrasse Tyson has pointed out, no serious attempt has been made to catalog every near-Earth object below about 140 meters. The next city killer could already be on its way from the direction of the sun, invisible to every telescope on the planet. We'd have hours of warning at best, maybe less, and there's absolutely nothing we could do about it except watch it approach. But if you think an undetectable asteroid is the scariest thing space can throw at us, the final entry makes every other incident on this list look like a minor inconvenience. The end of everything. Vacuum decay. According to quantum field theory, the Higgs field, which gives mass to every particle in the universe, may exist in a false vacuum, a state that appears stable but sits above the lowest possible energy level, like a ball resting in a dip partway up a hill rather than at the bottom. Through a quantum process called tunneling, a microscopic region of space could spontaneously drop to the true vacuum state. This would create a bubble of entirely new physics that expands outward at the speed of light, rewriting the fundamental laws of reality as it goes. And before you dismiss this as science fiction, understand that this is real physics. The discovery of the Higgs boson in 2012 placed our universe in a narrow region between stable and unstable, technically in the metastable zone. Stephen Hawking himself warned that the Higgs potential has the worrisome feature that it might become metastable, and the universe could undergo catastrophic vacuum decay, with a bubble of true vacuum expanding at the speed of light. Here's what would happen inside the bubble. Harvard physicist Sidney Coleman, who first described described the mathematics of vacuum decay in the 1970s put it starkly. Vacuum decay is the ultimate ecological catastrophe. In the new vacuum, there are new constants of nature. After vacuum decay, not only is life as we know it impossible, so is chemistry as we know it. Atoms would cease to hold together. The fundamental forces that bind protons, neutrons, and electrons would operate under different rules. Every molecule, every cell, every star, every planet dissolved and replaced by something unrecognizable, instantly. But here's the truly terrifying part. The bubble expands at the speed of light. Coleman wrote that if a bubble were expanding toward us at this moment, we would have essentially no warning of its approach until its arrival. You cannot detect it, you cannot outrun it, you cannot shield against it. Light itself is the messenger, and the destruction travels at the same speed. As researcher Jaka Vodev explained, whatever was in the false vacuum, so this would be us, would disappear immediately right when this bubble spread through us. Current calculations place the universe's expected lifetime against spontaneous vacuum decay at roughly 10 to the 790 power years, an inconceivably long time, but the probability is not zero. High energy events could theoretically nucleate a transition. In 2024, researchers used a 5,564 qubit quantum annular to simulate bubble nucleation for the first time, bringing the theoretical framework closer to experimental reality. Here's why this is the most terrifying entry on this list. Every other incident involves something that could kill you. A rogue asteroid, a magnetar flare, a solar storm. Vacuum decay doesn't just kill, it unmakes reality itself. It erases not just life, but the possibility of life. Not just matter, but the rules that allow matter to exist. It could have already started somewhere in the observable universe billions of years ago, with a bubble racing toward us right now at 300,000 kilometers per second. We would never see it, never feel it, never know. One moment, everything exists. The next, different physics, no atoms, no light, no thought. As Coleman wrote with characteristic understatement, the possibility that we are living in a false vacuum has never been a cheering one to contemplate. If you enjoyed this video and want to see more, click the video on the screen now.